develop a machine handling system which transfers 8 balls, ping-pong balls, 4 in each tube, to this box, all using integrated various sensors, actuator system, and a Raspberry Pi microcontroller. In this setup, we will be using several equipment and apparatus to achieve our goal. We have a conveyor belt, proximity sensor, 4 pneumatics, a PLC, a Raspberry Pi microcontroller, and an interface board. This is a proximity sensor. It functions to detect any object that is nearby it. How it works is, it sends continuous signal to the microprocessor, and if it sends any object, it stops sending signal likewise. This Raspberry Pi functions as the main input for all the information, also processes this input to produce output for all these components. Due to the low voltage of this microprocessor, we have to use PLC as the main voltage DC voltage output so we can actuate our systems. And this interface board functions as the intermediate between this low voltage microprocessor and also the high voltage PLC. The proximity sensor has 3 wires. The brown wire, which is the live wire, the black color is the ground wire, and the blue color is the neutral wire. The brown wire is connected directly to the PLC live. The black is connected to the interactive board. It is the one which sends the signal and to the microprocessor. And lastly is the neutral one, which is connected directly to the ground of the PLC.
The pneumatic system is a system which is controlled by the movement of air within the cylinder. For this case, the pneumatic system controls the movement of the ping pong ball into the box. There are 2 types of wiring system involved in this pneumatic system, which is the negative wire and also the live wire. The live wire will be connected to the PLC, and also the negative wire will be connected to the interactive board. Now I would like to explain about the working mechanism of the pneumatic system. First of all, the box moves in the conveyor belt and the sensor senses the box. The top pneumatic instrokes and the ping pong ball moves to the middle in between the top pneumatic and the bottom pneumatic. Then the bottom pneumatic instrokes moving the ping pong ball from middle to the box, and also the pneumatic outstrokes that. The same process is then repeated for the second ping pong box until it enters the box. Then the box moves to the second pneumatic system, and the whole process which happened in the first pneumatic system will be repeated in the second pneumatic system. Now in total there would be 4 ping pong balls in the box, which is 2 from the first pneumatic system and 2 from the second pneumatic system. The whole process then repeats until there are 8 ping pong balls in the box, which is 4 from the first pneumatic system and another 4 ping pong balls from the second pneumatic system, and that is it for the whole process. First of all, the main function for this conveyor belt is to move thing from one place to another place. For this The conveyor belt is used to move the box from one pneumatic system to another pneumatic system. Then the connection of the conveyor belt involves two relays, which are relay A and relay B. For relay A, is used to supply the power, while the relay B is for the movement of the belt back and forth. For the mechanism, the belt will move until the first sensor senses the box and it will stop. After the box is filled with two balls, the conveyor belt will move the box until it is sensed by the second sensor. At the second sensor, the box will be filled with another 2 ping pong balls. The whole process is repeated until there are 8 ping pong balls in the box. In this project, the box is used to collect the input. The box is designed so that the sensor could detect the box below it to allow the movement of ping-pong ball into the box. Thus, the height from the box is set to be not less than 0.2 to the sensor. Once the box has been detected, the ping-pong ball are dropped into the box from each of the pneumatic system. The process is repeated until the box is full with 8 ping-pong balls.
So this is going to be the code for our material handling system. This is in Python. So we're going to go through this code one by one. First, to access our GPIO pin of our Raspberry Pi, we must import the rpi.gpi module, and to use it, we're going to call it using GPIO. Next, we're going to import the time module so we can use the sync function later. Now we can declare our output. But before we declare our output, we must type in gpr.setMode
gpio.dcn so we can declare our outputs. Here I have declared all the inputs and the outputs. To declare the input, we have to type in gpio.setup, the pin number that we want to use, and then gpio.in for input, and if you want to declare an output, you have to declare using gpio.out. So I've declared 19 and 26 to be the left sensor and the right sensor, pin number 25 for top right pneumatic, pin number 23 for top left pneumatic, pin number 18 for bottom left pneumatic, pin number 24 for bottom right pneumatic, pin number 20 for relay B. Relay B is going to determine the direction of our conveyor belt. If relay B has an input, it's going to go in the clockwise direction. If it does not have an input, it's going to go in the anti-clockwise direction. And finally, GPIO 21, which is going to be relay A, which is the on and off for our conveyor belt. Before we start our line of code, we initialize all our outputs to be 0 just in case. Next, we're going to set our count variable to 0. Our count variable is going to keep in track the number of repetition of our system. So according to our system, we are going to transfer 8 balls into the box with 2 every time the pneumatic system works. So that's going to be a count of total of 4. And this while loop is going to make sure that our code only executes as long as the count is below 4. So the first thing that it has to do when the code is running is to make sure our conveyor belt is running. So gpi.output 21, which is our conveyor belt on relay A, is going to receive an input of 1. So now the conveyor belt should start running. For our system to work, our sensors need an input. So here we're going to use an if statement. So if gpi.input 19 is going to be our left sensor. So if our left sensor has a signal equivalent to false, keep in mind that for our sensor, false means that it detects an object. It will execute the following line of codes. So the first line of code, which is count plus equals 1, which means the first thing to do is going to add 1 to our count. This is to keep in track with the number of repetitions of the system. Next, it's going to off our conveyor belts. Make sure it stops running, so box stops right underneath the pneumatic system and the tube. Before I explain about the codes of the pneumatic system, I want to tell you guys that for the top pneumatic system, the pneumatic retracts when it has 0 input and extends when it has an input. But for the bottom pneumatics, it is vice versa. When it has no input or 0 input, its arm is fully extended, the pneumatic is fully extended, and if it receives an input which is 1, it will retract its arm. So from the video previously about the pneumatic system, the first thing that it has to happen is that the top pneumatic must retract first. So it receives a 0 input. Next is that the top pneumatic should extend its arm back, so it receives an input. If you have realized there is a time sleep function in between both of this line of codes, this is because when the code is running, everything is happening very fast. So if you are to put the code without the sleep function, the pneumatic is gonna retract and extend before the ball could pass through it. So for this, to prevent that, we have to put delay function, which is the sleep function. So I've delayed this for 3 seconds. So the pneumatic arm, once it is retracted, it will remain retracted for another 3 seconds. Only then will it extend. So after it extends, the top pneumatic extends. Next, the bottom pneumatic retracts its arm. This is to make sure that the ball falls on the box. After it has fallen to the box, the pneumatic extends back the bottom pneumatic, so it receives a 0 input. Now this process repeats again to make sure the second ball falls in the box. After 2 balls have fallen in the box, the conveyor belt starts running. Conveyor belt starts running and it runs in the clockwise direction. This is to make sure that the box is now moving from the left to the right pneumatic. Now, this line of code is going to be exactly the same for the another sensor, which is going to be for the right sensor, which is going to be GPIO input 26. But now we rename everything. So the top right pneumatic is 25 and the bottom pneumatic is 24. And also what's going to be different is the direction of the conveyor belt after it has dropped both balls. Previously we changed the direction from left to right. Now for the system to continue, the conveyor belt has to move from right to left, which means it's going to receive 0 input now. So here we're going to declare GPIO.output 20 to receive a 0 input, and here we have stated that the conveyor belt should now start moving. So after all 8 of the balls have entered the box, by right it have reached to a count of 4 and this while loop will stop. So after it has exited, the conveyor belt should stop running. So we have declared the conveyor belt on off relay A to have a 0 input.